Hello everyone. Today we have videos related to forces acting on objects. So in this example, I have an incline has an angle of inclination that is adjustable, which means I can change the angle of this inclined surface. A 20 kg block is put on the incline and the angle is increased until the block begins to slide. So we're getting that. If the coefficient of static friction is zero point 0.6 between the block and the incline, find the angle that causes the block to slide. So as a start, it will be a good idea if I can sketch the scenario of this question. So here's my inclined surface, this is my block, and if I want to do what we call the free body diagram, that's here is the force of the gravity or the weight. Here is the normal force generated by the surface. Now, this angle here, it will be the same angle between the y-axis and the weight, which means this component here will be mg cosine theta, and here is the mg sine theta. So it's the parallel weight component to the inclined surface, or the x weight component, whatever you want to name it, it's fine. And also we have the friction, which is going to be opposite to our motion. Okay, now let's deal with the equation. So if I take the total forces on the x-axis, it will be equal ma. That's from Newton's law. Now what forces I have on the x-axis? Now the motion is going downward, so it's sliding downward. So the mg sine theta, it will be the positive. Mg sine theta minus static force friction equal ma. All right. Now, when I say it's a static friction, it means there is no chance for motion. That's, we're trying to get to the point where the last moment that the static friction exists. So there will be no acceleration, which means mg sine theta will equal the static friction. Okay. Now, when I look to this equation, I can say, okay, that's mg sine theta. Static friction is the coefficient multiplied with the normal force. Now, the normal force, we can get it from the y-axis. So the total forces on the y-axis, it will equal ma. Again, that's from Newton's law. And here, there is no motion, no acceleration on the y-axis, which means this term will be 0. On the left-hand side of this equation, the normal force minus the mg cosine theta will be the total forces acting on the y-axis, and all equal 0. From here, the normal force equal mg cosine, or the cosine component of the weight. Great. Now I do have the value of the normal force, which I can place it here in the first equation. Let's see how it looks when I do that. So here we go. That's mg sine theta equal mu static friction multiplied by mg cosine theta. Now, when I look at these things, I can eliminate the masses, the gravity acceleration, and I will stay with the value of sine theta equal static coefficients multiplied by cosine theta. From here, I can just rearranging the formula. Sine theta divided on a cosine theta will equal the static coefficients. That will give me the tan, and here we go. That's tan theta equal, from here I can find the inverse tan, which is for the value of the static coefficients. So if we place the tan inverse in the calculator for the value of 0.6, That will give me 30 degrees point 9, so we can say it is 31 degrees. That's the angle will be enough to cause this object to slide downward. Okay, this is the way how we can handle incline surface. Generally speaking, we start with a free body diagram. Make sure you label all your forces. Make sure you put them in the right and correct directions, and then you treat the question. If you need something from the x-axis, you will use second Newton's law to find what are the net forces, or what are the forces, sorry, to produce this net force on the x-axis. If there is an acceleration or no acceleration on the situation, you apply the MA. If there is a need to involve the y-axis to find the normal force to help for the friction force, we can use it. Then we keep going based on that. In the next videos, I will apply more different scenarios going around the same subject. I hope you find this video useful, and see you again. Thank you.